So this is about the sound I was talking about in the last video. As you can see that these coils look really pretty good. So let me show you how I built it. So first of all I printed out the layout of the coil. Then I drilled the holes in the board and screwed in some screws. These screws will be used as a guide for coil shape. This winding process is quite labor intensive, but instead of doing this you can make a ring-shaped coil and then press it into shape. This simplifies the process to such an extent that you can make, say, 10 coils for 1 kilowatt motor in 1 hour. For the first prototype, when I used multiple coils, I spent about 1 hour for each coil. And this was because I want the coil to hold its shape, so I applied an epoxy after each layer or so. This method I am doing here has a disadvantage that you can theoretically make only flat coils. After you remove the screws, this coil can be pressed and its height can be reduced. I am fixing its shape right now by using small pieces of copper wire. This also forces the coil to have circular cross-section. Next I make a mold with one side that is flat. The coil was placed in the mold and poured by epoxy. After pouring the epoxy I realized that it would be a good idea to have a hole in center for a shaft. So at the last moment I placed some heavy round object at the center of the mold. When the epoxy has been cured I liberate it from the mold and perform a quick test. I found that the Hall effect sensor can work even from the other side of the coil. Only now I have realized that what you see here is a motor that doesn't require shaft coupling. You can mount the rotor on work shaft and the stator can be mounted independently. Of course there are many disadvantages and limitations, but as you can see it can be done quite easily. Now that I know that this coil works quite well, I can fix the bearing to the coil plate. To do so, I use the layout of the coil once again and line it up with the coil that I have. Then I lined up the bearing and seal it so epoxy doesn't get to the moving parts. Once again I used epoxy to hold bearing in place. I also poured epoxy on the coil so it will not vibrate that much. Now we can mount the rotor to the bearing. The previous version of the motor was constructed quite different, so vibrations there were absolutely minimal. As I'm looking at this construction, it's so simple that I believe that this is the cheapest motor per watt that can be built. However, to support this, I have to make some measurements. To measure the output power of your motor, you have to know what is your torque at given speed. You saw me using a piece of aluminum to brake the motor. This is in fact a proper way to introducing dynamic load. So in one of the next videos I will make a simple jig for measuring torque.